using 3 side lengths, construct that triangle starting at point A. All right, once you finish those triangles, show the people around you. Compare your triangles. Compare with you. You can't just draw a triangle. Come on, man. Oh. All right. So, ladies and gentlemen, there is my triangle. Anyone have one that looks the same there? Almost looks like that. How about now? Okay, so guys, given 3 side lengths, is there any way to make a different triangle? Can you make a triangle that is not congruent using those side lengths? Not congruent to mine using those side lengths. No, it's not possible. Okay. Therefore, what we've done is we've kind of demonstrated the next triangle congruence theorem. Okay. If you look in page 145 of your student journal, last week we talked about side angle side. Today we're going to cover 2 other ones. One is called side side side, and that's the one we just kind of demonstrated with that little exercise there. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. All right? By side, side, side. So we have side angle side, and now we have side, side, side. We use SSS. Okay? We also have one other one that we'll talk about today, and it's a bit different. Remember last week we said that the angle has to be included in between the 2 sides to have side angle side. Well, there's one exception to that rule, and it's when it's a right triangle. When it's a right triangle, if you have a right triangle and the hypotenuse, which we call our longest side, and one of the legs, one of the other 2 legs are congruent, we can prove that that triangle is congruent by hypotenuse leg. Okay, and we're not going to demonstrate that one with a construction here, but if you have a right triangle and the hypotenuse is congruent to the other hypotenuse of another triangle, and one of the legs is congruent to another leg of that same triangle, then the triangles are congruent by the HL, or hypotenuse leg theorem. Okay. So, yeah. Is this the same as side angle side? Hey, why isn't it the same? Uh-oh. This is angle side side, right? And if we abbreviate angle side side, that's bad. There's going to be no swearing in this class. Okay? So it's side angle side would be in between. Okay? Yep. It's a good question. We don't need to do any bad words in here. Okay? Hypotenuse leg. Yes? HL? Yeah. You see what I mean? We shouldn't have to abbreviate that up. All right. Any questions? Okay, I want you to look at page 146 of your student journal. And page 146 says, decide whether the congruent statement is true and explain your reasoning. So, explaining our reasoning would be just listing our reasons. So, for instance, given, reflexive, vertical angles, and HL. Or given, reflexive, side, side, side. Okay? You just have to list the reasons. No statements needed. So 1 and 2, off you go. Work together. So on number 1, ABC congruent to EDC, how many say true again? How many say false? What are the reasons? First reason. No, can't say side, side, side until we say, Sam? We have the givens, okay? The markings here show AB to ED and BC to DC. And then, what's the next one? AC to EC. We have, we have our given, and Brennan? Do we need vertical angles? We don't have vertical angles, but we don't need them either. Yes? Don't have reflexive, we don't need reflexive. We have three sides congruent to three sides of another triangle. What do we call that? SSS. We can use side, side, side. Based on side, 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 three sides congruent, those triangles are congruent. Okay, let's take a look at number 2. Number 2, we have our given. And then we have? Yeah?
Line HK is congruent to line KH by reflexive property.
Okay, good. We have reflexive. And then we have? Who? SSS. Side, side, side. Okay? So we have the givens, we have the reflexive property, and then we have SSS. All right. Notice if we were to make this statement, we'd have to say HK to KH, because if we folded this shape, it wouldn't lie perfectly on top of itself. J would move over here, and G would move over here. All right. Any questions on those two? Okay, the next two. How many are already done with those? A bunch of you had already started them. Okay, let's talk about them. So UVW and XYZ. Let me say yes. Let me say no. This one is, well, let's see, U to V, okay, and X to Y. What's wrong there? They're the opposite. What's that mean? Let's start this again. U kind of looks like the right angle. I don't know if it is. But U to V. And then X to Y. What's wrong with that? Yeah. Because they're not in the correct order. Yeah. They're not corresponding. So U to V should say Y to X. Right? Okay, so this is no. All right, we should actually have UVW is congruent to YXZ based on side, side, side. So our statement is incorrect right here. Order matters. All right, questions? Yes, sir. You could, 3 angles don't work, right? Because think of a equilateral triangle. You could have a really big equilateral triangle and a really small equilateral triangle, but they have the same angle measures. Okay? 3 angles prove similar, not congruent. Okay, let's look at number 4. Did it work? RST, so R to S, and then R to P. That works. Okay, and then P to Q. And S to T. That works. Okay, so this is yes by, what do we have? Given and side, side, side. What else could you use if you made one more reason? Jordan? Yeah, if you said vertical angles, then you could use what? Side, angle, side. Okay, you could. It would be take one more step. You don't have to use vertical angles here, but if you did, then you could use side, angle, side as well. Questions on 3 through 4? All right, everyone take a look at number 5. It says determine whether the figure is stable. Stable means it's not wobbly. Okay? It's not going to shift. All right? Talk to your neighbors. Explain your reasoning. Okay, so hey, this line right here is parallel or is congruent to that one, and that one is congruent to that one. They're the same lengths. Now, they don't really tell us that, but if those are the same lengths and we have this side congruent to itself by reflexive, is this stable? Yeah, it is. Okay? The diagonal that supports this makes this figure, makes those two triangles congruent, and those two triangles are not going to stop being congruent. So you can't shift that. By side, 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 you got two congruent triangles. that figure is stable. Okay, any questions? We'll try some proofs here. Get a little more complex. Take a look at number 6 on page 147. All right, give it a go. Work with your groupies. It says redraw the triangles so they're side by side. That may help some of you. If it helps you, then do it. All right, this one. First step. Someone from the back row, what do you got? First statement. Brendan, what do you got? Yeah, we have the given. B is the midpoint. Of CD. All right. Okay. What's the second one? You know, I forgot part of my given here. Let me finish that and then I'll get that from you. AB is congruent to EB and angle C and angle D are RT angles. All right. Sorry, Jeremiah, what was that? DB is congruent to CB, not by the reflexive property. But that's true. It's a good statement. What's the reason there? Definition of what? Yeah, definition of midpoint. Okay, by the definition of midpoint, we've stated that up here. We know that these two segments are congruent now. All right, so I'm going to mark them over there. Good. Yeah?
I said angle B is congruent to angle B by the reflexive property.
Angle B is congruent to angle
B.
So like this one and this one?
Yeah.
Can't use reflexive right there. Reflexive means they're the exact same angle. Like they would be lying on top of each other. Like it would be like me saying, here's a triangle, calling that angle A, and then here's another triangle. So I could say A is congruent to A because they're the same angle. Okay, so I can't do that on this one. Yes, Ian. I could use that. So here's the deal on proofs right now. Guys, where are we trying to go? We're trying to prove these two triangles congruent. So let's have a plan of attack. So what are the 3 things we can use to prove triangles congruent? What's the one we learned last week? We could use side angle side, which means we need 2 sides and then included angle. Okay, right now we have 2 sides. We need this angle, which is, I think, what Drew was trying to get. Okay, what else could we use? Yeah, we could use side, 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 so that would mean we need this side and that side. What else do we need? Could we use? Yeah. Yeah, HL, hypotenuse leg, which means we need a hypotenuse and a leg and one other thing. Now, it doesn't state it right here, but what's the other piece that we need with hypotenuse leg? When can we use it? Yeah. We need the right angle. So we have a hypotenuse, we have a leg, and we have right angles. Therefore, as long as we say they're right angles, which they do. Okay, so really we should state that these are now right triangles. Okay, so Ian, we could state that they're congruent, but it would be an extra step. All right, so if we just say triangle ABC and triangle EBD are right triangles. Okay, we know that by the definition of right triangles, they have right angles. We can now use hypotenuse leg. So ABC, I could write ABC is congruent to triangle EBD by HL. And then we end it with our cool little end. Okay. Questions there? Yes, Alex?
So, could have you used the SAS theorem?
Side angle side?
Yeah.
We need the included angle here. We need this angle. Can't use vertical. Vertical would mean I'd have to split it this way and split it this way, so this whole angle would be congruent to that whole angle. Yeah. Can't use vertical there. All right? Notice you have to state they're right triangles because because we didn't say that. So hypotenuse leg, you need right triangles and a hypotenuse and a leg. Okay, number 7. Take a look at it. Give it a go with your groupies. All right, well, let's get a start here. So what's our first statement? Someone from the front of the room here. First statement. Alex?
Line IE is congruent to line EE is congruent to line JL.
Okay, so the givens, right? All right, so I think, like in this case, these givens are insanely long. I mean, that could take forever, man. Or at least feel like it does. There's a question last week also by someone in class, and the book had withheld the little symbol above 2 letters. So for instance, on this where I write HG, they said, hey, does that mean line segment? And just remember that means the same thing. That's what they're referring to there. All right, holy cow. Okay, second. So we had all those things congruent. Good thing they marked them all. What else could we do? Let's think about what we're trying to prove first. EFG. Let me trace these here. Trying to prove EFG, this big dog right here, congruent to this big one right here. Okay? Are they congruent? Yeah, I mean, you can kind of go, well, duh, yeah, like that's equal to that and that's equal to that, so they have to be. Now, how do we state that? Drew? Okay, then you can use side, side, side. Okay, that is kind of the way you have to go. It's just proving that this line is congruent to that line. Yeah.
So what I did, I stated all the midpoints first.
Okay.
So if you have a midpoint, and that means that
It cuts the line in half.
yeah, and then
Let's define the lines, okay? This line right here, H, or actually let's go with EF. EF is made up of what 2 segments? Yeah, it's equal to EK. Oops, I guess I should write it correctly. EK plus KF. Everyone agree? Okay. So we also could say then that EG is equal to what 2 things? EL and LG. Okay, so notice if I say those 2 things right there, I can kind of keep going through that process. Say FG is equal to FH plus HG. Okay, I could then say IH is congruent to IK and KH, or is equal to IK plus KH. JH is equal to JL and plus LH. And then I could go, did I already get IH? Yeah. IJ is congruent to IE and EJ. Is equal to IE plus EJ. Okay. Now, how is that helpful? Well, first, the statement is, that's called the segment addition postulate. segment addition postulate. That just says that the segment's made up of these two parts, you put those two things together, it makes the whole segment. How does that help us? Well, we know that KF is equal to, KF is also equal to EK. Right? So I could actually say that EF equals, if I replace this right here with EK, how many EKs are there now? That's one EK plus another EK gives us how many EKs? 2 EKs. So EF is equal to 2 EK. And I could do the same thing here with FG. I could say FG is also equal to, well, FH and HG. Well, FH and HG is also equal to EK. Right? So I could say FG is equal to 2 EK. How? Because I know that that's equal to EK, and I know that that is equal to EK. It says it up there. Yeah, I could keep going through that. I could say EG is equal to what? Yeah, it's equal to 2 EK. So if I say that for all of those, IH is equal to 2 EK, JH is equal to 2 EK, and IJ is equal to 2 EK. The statement behind that is I'm just using substitution. Just substituting the values in there. Okay, so based on this now, I actually could state that HI is equal to EF. How does that help? Well, I have HI is equal to EF. So I've got two sides congruent. So I could now go into my sides being congruent. I could say IJ is congruent to, so this guy right here is congruent to FG. And I could say that JH is congruent to GE. All of those are by transitive property. I've now stated 3 sides congruent, so my final statement, which I'm running out of room for, I didn't give myself enough room, would be my triangles. Triangle EFG is congruent to triangle HIJ by side, side, side. Okay, that's a pretty involved proof there. That's how you go through and take care of it. All right.